Hello, in this video I'll be showing you a basic proof for the Pythagoras Theorem. So there's millions, well not millions, there's a lot of ways to prove Pythagoras Theorem. So Pythagoras Theorem is used for right angle triangles, and it's one of the most famous theorems in maths. So if you have a triangle, and let's just label them A, B, and C, and it's a right angle, A squared plus B squared will equal C squared. And that's true no matter what values of A, B, or C. But how did people come up with this? How did they know this was true? Okay, so I'm going to show you that today. This is more of a proof video, so there'll be no questions, like questions to solve in this. It'll just be showing you where this formula comes from and why it works. All right. So first off, we're just going to have a triangle here. And we're going to have side lengths are B, A, C, and it's all going to be right angle. Oh, whoops, I'll just draw a bit better triangle. Okay, so you have a triangle here. It goes B, A, and C, and it's right angled. And let's say, so we don't know what A, B, and C are. But let's say we have 4 of these triangles. So I'm just going to draw these triangles in a particular way. So we have the first triangle there, and then we have another triangle here that's up along here. The B is up here, the A is here, the right angle's here, and the hypotenuse is still C. Right? That's our second triangle. Then we have our third triangle up here, and we're just going to draw it out. It's going to go up here. And this is going to be A, B, C, right angle there. Right? And then we have our last triangle. We have our B here, a C going up there, and our A there. I know these aren't very good triangles, but you get the picture of what we're actually looking at. So I've got 4 triangles of just the casual A, B, and C, and they're all right angle triangles, okay? We're looking at this here, and basically, since we're looking, what are we looking at exactly when these all these triangles are put together? We're basically looking at a rectangle. The reason we know it's a rectangle, is because this entire side here is A plus B, and this entire side here is A plus B. All the sides are the same. They're all A plus B, right? And we have 4 edges, we have 4 sides, and they're all right angled. So the definition of a squared is having 4 of the same side and they're all right angles. All right angles. Okay? So that's what we're looking at. We have a rectangle in here. Now, to ask you, what we want to know is, we've got 2, not rectangles, I'm sorry, squares. Sorry, I've got that completely, I keep saying rectangle. These are all squared. This is a definition of a square, not a rectangle. Okay, so this side here is A plus B, and they're all A plus B. We have 2 squares in our midst. So we have the square A plus B. We also have one on the inside that we can see in here. Okay? What would be the area of that little square? So recall, the area of a square is the length or squared, otherwise known as length times length, because they're all the same. Okay? So the area of this inside squared, the area of the inside squared here, would be equal to C squared, because the sides of this little square are all C's. Okay? So I'm just going to move all this information up into the corner now, so it's out of our way. We have our 4 triangles there. I'm just going to we're just going to ignore the area in the middle now. We're going to have our 4 triangles again, except we're going to move this triangle up. I better use a different color so it doesn't confuse everyone. So take our diagram here. We're going to take this triangle and we're going to rotate it so it goes up here. So I'm just going to draw what I'm talking about. So we have A, B, C. So that's that triangle there. And we're just going to move this triangle up there, that way it slots in here. So we have this triangle here, we have A, B. I'm just going to move that up, right? And we have a right angle there. I'm also going to move, I'm going to move this, triangle across as well. So we have this triangle down here. So we still have this triangle here. So we have A and B, and now we have this triangle I've moved across from here. It's right angle here, and this is now this side is B and that is A. Okay. Now all I'm going to do is basically I'm going to shift this entire thing over to the side just a little bit. Okay. So I'll see if I can select it. If not, that's alright. No, that's not going to work. Alright, so I'm just going to draw what I'm going to do. So I've got that picture. All I've gone from this image to that image, and now I'm going to shift this little rectangle across a bit. So we're going to have this up here. So we're going to have A, B, B, A. And we're going to have over here A, B, A, B. Okay. So I've just shifted that rectangle to the right hand side just a little bit. Okay. So I've just gone from this image up here down to this image down here. Alright. I haven't really changed anything. Okay. And now I'm just going to pretend I want the area of this little square here and this little square here. Okay. What would be the area of this square here? The area of that little square there would be the sides times itself. So the area in there would be A squared. Okay. The area in here would be the same as this sides times itself. So the area up there would be B squared. Okay. Just taking a look at our square we have down here. They're still the same square as we had up the top in the, we still have the same square here as we did up here. Okay? Because this side here is B, that side's B, that is A, that is A. Okay? So this entire thing here is A plus B. This entire thing here is A plus B. Okay? So if we just ignored the middle bit here, if we just, actually no, not ignore the middle bit, alright? So we have both these squares, so both of them are actually equivalent. So I'm just going to move this down here. I'm going to rub this out. Okay? So this, just move that up a little bit. Both of these are equal. Okay? So if we were to remove the triangles from both of them, so let's say we just removed that triangle, and we just left the rectangle in the middle on that side, we're just left with that square there, and we remove the triangles here and move the triangles there, we're left with two little squares on the left hand side equaling 1 squared on the right hand side. In other words, we're equal to A squared plus b squared is equal to c squared. Because this whole thing, its area is b squared, and this whole thing is a squared. And the sum of these two is equivalent to the right hand side, and this whole area here is c squared. Therefore, a squared plus b squared equals c squared. That's a mouthful. So that's a proof for the Pythagoras Theorem. I hope you enjoyed the video, and I hope you learned something from it. If you want any follow-up videos on this stuff, just give it a shout in the comments. Thank you.